Hi, see you again. This topic is about ultrasonic sensor. In Chinese, ultrasonic is 超声波. 超声波 sensor is 传感器. 传感器. So, topic is 超声波传感器. Normally, we use HC SR04 ultrasonic sensor. And this sensor has two pins, and one is echo, one is trigger. The principle is trigger pins will transmit the sounds, and when the sound hits something, will be reflected, and the echo pin will receive the reflected sound and detect this time. And our program will automatically calculate this relationship between distance and time. So it's very easy for use this sensor. How to connect to our Raspberry Pi? This is connection. Connection in Chinese 连接. Remember? Okay. One is 5 volts, one is ground, except that 2 is echo. Echo, for example, now we can connect to any available pins. For example, in this one, we connect to GPIO 17. But pay attention, we are not directly connected to GPIO 17 because this voltage is 5 volts. But for Raspberry Pi, signal normally around 3 volts, so we need to use voltage divider. So here we connect two resistor. One is 330, one is 470, and then we use this divider to connect our GPIO 17. For trigger, in this example, we connect GPIO 4. Of course, trigger and echo, you can connect to any available pins, not only 4 and 17. Okay, before we program, we need to study some new statement. Today we study while loop. While loop. This is syntax of while loop. While is keyword, then test expression, colon. After that, we have some instantation. After that is body of while. If you study the other language like C language or Java language, you will understand the while is simple. We first go inside to this loop and test expression. If result is true, we will execute body of while, repeat this loop, and if sometime test expression result is false, we will go outside of loop. I equal 1 while I less than 6. See here, when you press enter, Sony will automatically give you full space. This is indentation, because only with the indentation, that means this statement is inside the loop. Okay, print I, enter, I plus 1. So I will automatically plus 1. For example, when you enter again, there is indentation, but I don't need this indentation because my loop already finished, so you can delete that. For example, I print another sentence. Loop is finished. Okay, let's execute this program. See, here is the results. I is equal 1, so first print 1, then I automatically plus 1. Then test is I less than 6. Of course 2 is less than 6, so execute loop again. So press 2, continue 3, 4, 5 until I is 5. After that test after 5 is 6, so now 6 is equal 6. Then this loop will finish. After finish, we execute the statement after loop, so that is loop is finished. This is leads example. In Chinese is leads. Sometimes we also use infinite loop. There we use the while true. Then because this statement, this test always true, so loop can always execute no finished. So let's try. This one, while true, then we print pay attention. For the loop we need indentation, that is 4 space, so 4 space, print hello. I try again. See, always print hello, no finished. So this is infinite loop. Pay attention. For Python, this true, capital and lowercase, they are different. If you print this is lowercase, let's see, arrow. So must capital T. Before we introduce GPIO0, this library includes a lot of input-output. And today, because we use ultrasonic sensor or distance sensor, so we will use this class, GPIO0's distance sensor class. This class, if you want to more detailed information, you see, we already download the GPIO0 documentation, and in this chapter is about the distance sensor. Introduce these libraries, some arguments. Here you see there's argument include echo, which pin connect the echo, and the trigger pin, and like marks the distance threshold. We will introduce later. Let's do the first example. I want to use this distance sensor, measure the distance and print to my Raspberry Pi. So from GPIO0 import distance sensor. Pay attention, distance sensor D and S is capital, and from time import, this is a time library. We import a function is sleep, because sleep means wait for the execution of program. And we create a instance sensor, create that. First example, we just use 2 parameter. Tell Raspberry Pi which pin we connect. For echo pin, we connect to 17, right? And for trigger pin, we connect to 4. And we begin to our loop, while loop. While true, we print distance is our output result is instance sensor dot distance and then print meter here, print meter. because we need a refresh result, so I need sleep 1 second, then repeat again. That means every 1 second I repeat results. So okay, now let's test our results. I run the program. See, now distance is 1 meter. That's the default result. And if I put something here, see, I make a long distance. Close. Okay, we see the results. A little problem is this result too many digitals. I don't want that, so I can use the format function to change. For example, I only need 2 digital after the dot sign. So here I can use some format control. For example, now I use here census distance. I use colon and dot 2f. That means after dot I only need 2 digital. Now let's try again. Run program. See, 0, only 2 digital. Right. So this is our first example. Okay, second example, I show you how to print our distance to the LCD. LCD last week we already introduced, and so I give you this example. Here, you can see we create an instance sensor, use classes distance sensor. But here we use another parameter because max distance, that is the max distance the ultrasonic can measure. Normally this sensor can measure like 4 or 5 meter, but default max distance is 1 meter. So here I want to measure within 2 meter, so I give value is 2, and also create a LCD instance. We have introduced that. Then LCD writing string, that is in the first row we write distance is what. Then while loop we make the cursor's position at 1 0. In fact, that is second rows, right? Second row, and then write our result distance. Every 1 meter we will refresh 1 time. So don't forget import. This is import time, import RPLCD, import GPL 0. Let's see. Run the program. Can you see if without no default distance is 2 meter, then I put something here. File. See, this is LCD display. So when I move the distance, display change. Before next example, I want to introduce function. Function in Chinese is 函数. 函数. Function we need has 2 parts. One part is syntax of defining a function. How to define a function? Define function, we begin with keyword def, and then give the function name. Function name includes some parameters or without parameter. Then colon at next line with indentation. Don't forget indentation. Then is your statement. This is a definition. And for calling a function is easy. Just use the function name with your arguments. For example, this example, let's see. Here is define part with diff, then greet user is your function name. Parentheses, there is no parameter, so inside parentheses is empty. But maybe sometimes you need with parameter. Then colon at the second line. Here is indentation. Don't forget, indentation is 4 space. Then I print hello. So this part very simple, is definition of function. Then I call function. Call function just use the function's name and parentheses. So I try this one. See, result just print hello. This example very simple. Maybe function is not necessary, but if for some repeat use code, if every time you print a lot of code, that is not easy. So we can define a function. Okay, let's say our third example. Third example, I want to give this distance some threshold distance. While the object inside this threshold, and our system will give a warning. Warning what? Too close. If outside of this threshold, and no warning. So here we import str GPL 0, IP LCD, and time. When you create an instance of sensor, we use another threshold distance, this parameter. And also when we use a loop, we use two methods. It's sensors when in range and when out of range. How to use that and what's that mean? We can check the GPIO documentation. Now, this is threshold distance. The distance measured in meters that will trigger the when in range and when out of range. So this is threshold for trigger these two events. So when in range is an event, and when out of range is another event. So threshold, for example, I give a parameter is 0.1 meter, while something inside 0.1, there's an alarm. If outside, no alarm. So I define alarm function. We'll write to LCD to close this information, and define another clear alarm function. If something outside the threshold, we print nothing. So there is some space, print nothing. Let's see program. While the true, this is infinite loop. First row, we make cursor position at 0, 0 is first row, and write our distance and the results at second row. While the sensors when in range event is triggered, we will assign alarm function. If all out of range, we will trigger clear alarm function, and every 1 second we will refresh results. Let's see result. Run. Now the result is 0.44. No alarm. But if I make close, now result is 0.02. See, alarm is too close. 0.07 also too close. Now 0.1, 0.14, no alarm. Close again. Alarm. Welcome, subscribe to Confucius Institute's YouTube channel, and we will share a lot of interesting technology, automation technology, include like Arduino, even PLC. Anything you are interested, just leave a comment in Confucius Institute channel. See you next time.